Hello and welcome to the AI Innovators Podcast, where we dive deep into the latest advancements in AI technology and research. I'm Olivia, your host, and a principal AI researcher with expertise in Gen AI frameworks, distributed systems, and system architecture.
And I'm Ray, an AI research engineer specializing in ML ops, framework optimization, and the research to production pipeline. Today, we're exploring some exciting developments from the latest research papers on AI agents, covering everything from infrastructure to collaboration mechanisms. Let's get started.
First up, we have a fascinating paper titled Beyond Browsing, API-Based Web Agents. This work introduces agents that combine traditional browsing with API calls. Ray, from a technical standpoint, how does this hybrid approach enhance the performance of AI agents?
Great question, Olivia. By leveraging APIs, these agents can bypass the latency associated with parsing raw web content. According to performance benchmarks from the Web Arena, this hybrid approach offers a 24% boost in efficiency. Think of it like using a direct database query instead of scraping web pages. It's faster and more reliable.
Exactly. And when we visualize this, imagine an architecture diagram where the agent acts as a middleware, interfacing seamlessly with both browsing components and API endpoints. This dual approach not only streamlines data retrieval, but also sets the stage for robust automated web processes.
Moving on, there's a paper on infrastructure for AI agents that proposes integrating AI agents into broader legal and economic systems. Olivia, what are the architectural considerations here?
The paper outlines protocols similar to HTTPS for authentication and regulatory compliance. From an architectural perspective, this involves designing secure pipelines for data exchange and implementing robust accountability measures. The system must ensure that these agents operate within predefined legal boundaries, which is crucial for societal trust.
I see. And implementing such an infrastructure would require careful consideration of security layers and risk management protocols. It's like building a distributed system where every node, or in this case agent, is accountable and secure.
Precisely. Now let's dive into the Agentic Systems paper, which explores vertical AI agents leveraging large language models. Ray, from a system design standpoint, how do these standardized design patterns enhance scalability?
These patterns introduce a cognitive skills module for domain-specific reasoning. Essentially, it's about modularizing the cognitive capabilities of agents, allowing for more scalable and industry-specific solutions. Imagine a microservices architecture, where each service is tailored to a specific domain, yet they all integrate seamlessly.
That's a perfect analogy. By adopting standardized patterns, developers can deploy scalable AI solutions quickly across various sectors, enhancing both performance and adaptability.
Next, let's look at DeepSeek R1, which uses reinforcement learning to improve the reasoning capabilities of LLMs. Olivia, what are the key implementation challenges here?
One challenge is the multi-stage training process, which requires precise tuning of reinforcement learning parameters. This involves balancing exploration and exploitation to optimize the model's reasoning abilities. Additionally, integrating these improvements without compromising existing performance is a delicate task.
Definitely. Performance benchmarks show that DeepSeek R1 achieves reasoning capabilities comparable to leading models like OpenAI O1, which underscores the importance of rigorous testing and validation during implementation.
And speaking of rigorous evaluation, the Intel Agent Framework offers a new way to benchmark conversational AI. Ray, how does this framework enhance performance diagnostics?
Intel Agent uses graph modeling and policy-driven evaluation, which allows for detailed analysis of conversational flows. It's like having a debugging tool that maps out potential performance gaps, enabling continuous improvement in AI interactions.
Exactly. By providing an open-source platform for these assessments, Intel Agent supports scalable and precise analysis, which is essential for developing reliable conversational systems.
Moving on, the paper on AI agents for computer use reviews instruction-based agents, highlighting a shift towards general-purpose foundation models. Olivia, what integration patterns do these models present?
These models emphasize natural language processing capabilities, integrating seamlessly into existing digital workflows. From a system architecture perspective, it's about embedding these models into user interfaces, enhancing human-computer interaction through more intuitive command structures.
It's fascinating how these general-purpose models can transform digital workflows, making them more accessible and efficient.
Absolutely. Now let's discuss governing AI agents. This paper critiques traditional governance mechanisms and suggests new legal and technical infrastructures. Ray, what are the technical trade-offs involved here?
One of the main trade-offs is between transparency and operational efficiency. Implementing comprehensive governance frameworks can introduce overhead, but ensures ethical deployment. It's like adding checkpoints in a pipeline, necessary for accountability, but can slow down execution.
That's an important consideration. Balancing these trade-offs is crucial for sustainable AI deployment.
Next, Search-O1 enhances reasoning models with agentic retrieval augmented generation. Olivia, how does this approach improve system reliability?
By dynamically retrieving and analyzing information, this method addresses knowledge insufficiency. Imagine a search engine that not only retrieves data, but also contextualizes it for deeper understanding, improving system reliability in complex domains.
That's a powerful enhancement. Onto multi-agent collaboration mechanisms, which surveys LLM-based systems. Olivia, what are the integration strategies outlined here?
The paper categorizes collaboration mechanisms into frameworks that support extensible and scalable multi-agent systems. From a technical perspective, it's about designing flexible architectures that accommodate diverse collaboration strategies, enhancing scalability and cooperation.
Indeed. Finally, the COCO framework introduces co-planning and co-execution models in document editing. How does this impact human-AI synergy?
By structuring interactions into co-planning and co-execution phases, COCO enhances agent steerability and usability. It's akin to having a project manager who not only plans but executes tasks collaboratively, streamlining workflows and enhancing productivity.
That's a significant step forward in human-AI collaboration.
These papers collectively highlight the evolution of AI agents, becoming more efficient, accountable, and collaborative. As these technologies mature, they're poised to redefine automated systems across industries.
It's exciting to see how these advancements are laying the groundwork for the future of intelligent systems.
Absolutely. Well, that wraps up today's episode of AI Innovators. Stay tuned for more insights and discussions on the latest in AI research and technology.
Thanks for tuning in, everyone. Until next time, keep innovating.